Here's an interesting question. For every positive integer a, the unit digits of a1, a2, a3, a4, a5, so on, will form a repeating sequence. In each such sequence, the smallest number of consecutive unit digits that repeat consecutively and indefinitely is at most 4. This number is called the cycle length. For example, when a equals 3, 3 to the power 1 equals 3 to the power 2 equals 9, 3 to the power 3, 27, 3 to the power 4 equals 81, and so on. And the sequence of unit digits is 397139. In this example, the consecutive unit digits that repeat are 3971, and so the cycle length is 4. Okay, the first question is, the unit digit of 3 to the power 43. This one is really easy. We just do 43 over 4, and the remainder is 3. So we count 3, 1, 2, 3. To the left, the unit digit should be 7. Second question. Determine the number of integer j which j is bigger to or equal to 1 but smaller or equal to 2026, for which 4 to the power j plus a to the power j is a multiple of 10. So this one is also really easy. The first thing first, we factor out the 4 and 8. So 4 is 2 to the power 2, and 8 is 2 to the power 3. And the cycle for 2, second thing is cycle for 2. We find out is 2, 4, 8, 6. 2, 4, 8, 6. And it's also a cycle length of 4. And since we're looking for the multiple of 10, we know the ending part has to be 2 plus 8 or 4 plus 6. So there are only 2 cases. We name this case 1, this case 2. Now we start to investigate them one by one. For the case 1, we're looking for 2 ending with 2 and 8. So since it's become 2j and it's plus 3j, okay. 2, 3j. So, which means we can think this 2j is 2k. And here, by changing k, the unit digit of the first term will only be 2 to the modular 4 if k is an even number. Wait. The second question. Determine the number of integer j with j bigger or equal to 1 and smaller or equal to 26, for which 4j plus 8j is a multiple of 10. Okay, this is easy. So first factor to observe the pattern. 2 to the 2j is equal to 4 to the power j plus 2 to the power 3 times j is equal to 8j. And we're looking for the multiple of 10, which it means unit digit should be ending with 0. And by observing the unit digit cycle for the 2, we see it's a cycle length of 4, and in a pattern of 2, 4, 8, 6. So the only possible cases are 2 plus 8 and 4 plus 6. First, let us inspect the first case, 2 plus 8. Here, since it's like 2j to the power plus 2 to the power 3j, we can consider only the top exponent part first. So we written first 2j, the exponent part. We observed trying to find a pattern. So we consider in two cases. First, 2 times 2n for the even, and 2 times 2n plus 1. For the odd cases, 2 times 2n always congruent to 0 modulo 4, and for all the odd number, it's always congruent to modular 4. So which means when j is odd, it will always be 2, the second number, which is 4. And when j equal even number, it will always be 6, which is impossible for us to see neither 2 or 8 here. So this cases is impossible. So right now we consider the second cases. 4 plus 6 equal 10. Since from here we already see the pattern for 2 and 2j, we only need to see the pattern for 3j. So 3j, it's congruent 0 modulo 4 for j equals 0 equal congruent to 1, or congruent to 3 for j equal 1. My bad. And congruent to 2 for 3, and congruent to 4, congruent to 1 for j equal 4. And matching up with 2j, which is 0 for even, 2 for odd. And we see the only one that meets our requirement is 2, 0, this pair. Since other pair doesn't match, so yeah. Since this is because the pattern of 2, cycle of unit digit 2 is 2, 4, 8, 6, 2, and right now we're looking for the remainder of 2 and 0, and only one that match is this paired. So back to our problem to see what thing we need to do. Okay. After we see the two cases, we see only 4 plus 6 case works, and if and only if when j is congruent to 2 to the modular 4. Okay, based on this, we do 2026 divided by 4 equal 506 with a remainder of 2. So our final result is 506 plus 1. Since here is still left with the 2, which still can plus 1. And our final answer for B is 507. Okay. Here, let us look at our last question C. Determine the number of integer k with 1 smaller or equal to k smaller or equal to 50 for which 2k plus 3k has the same unit digit as a to the power 2026k plus 9 to the power 2026k. First step, we list all the important information. We'll circle it. 2k plus 3k, this one, and this one. A to the power 2026k plus 9 to the power 2026k is equal to 2 to the power 3 2026k plus 9 plus 3 to the power 2 times 2026k. Then we list 2k plus 3k below it for comparison. And also list the cycle for unit digit. For 2 is 2 for A6, and for 3 is 3971. Okay, now let us carefully examine the expression. We see here, after translate to this format, we can see this one should equal to 4x. If the 2 times 2026k is congruent to 0 modular 4. This one is 0 modular 4. Why? Because here there's a 2, and in 2026 this number there's another 2. 2 times 1013. Okay. So this means this term, the unit digit only could be 1, which largely eliminates our choices here. So the only choices are 2 plus 1 equals 3, 4 plus 1 equals 5, 8 plus 1 equals 9, and 6 plus 1 equals 7. And here we go back to the 2k to the power k plus 3 power k. Since here the exponents are same, k, which means the possible unit digit for this one is 2 plus 3 equals 5, 4 plus 9 equals 13, 9, 8 plus 7 equals 15, 6 plus 1 equals 7. Here we can see these two match. These two match. Okay. First, we consider a case where we want our k is congruent to 0, because here k is congruent to 0. Okay? So when k congruent to 0 modulo 4, we get 3 times 2026 k should also congruent to 0 modulo 4. Which means as long as k is the multiple of 4 for x, they will have the same unit digit. So we do 50 divided by 4, we should get 12 with the remainder of 2. This is the first case, 6 plus 1. And now we come here to our second case, which is 4 plus 1 equals 5. For 2 to the power k plus 3 to the power k, if we want to get a unit digit of 5, we have to let k congruent to 1 modulo 4. And this leads us to get the exponent part of the 2 is 3 times 2026 k congruent to 2k, since 3 times 2026 is congruent to 2 modulo 4, 2k congruent to 2, since k here is 1 modulo 4, 2 modulo 4. What's next? So this means as long as k is congruent to 1 is equal to 1 plus a multiple of 4, we can get our desired number, since here 3 times 2026 k, if k congruent to 1 modulo 4, we get 2, which is exactly the same thing we want, which is 4. Here, which is the second number of in a cycle of 2, unit digit of 2. So now, based on this, we wrote 50 minus 1 bracket over 4 plus 1, because we start from x equals 0 and we get 13. Here we just ignore the remainder. Okay. So our final answer, put them together, is 13 plus 12 equal 25. And here is our final solution for question 3 per C in the Galois 2026. Okay. Thank you for listening, and please subscribe.